Friends, in this video, we will learn the very basics of some probability concepts. Okay, we'll take very simple examples so that we know uh, the all possible outcomes and we know the favorable outcomes so that we can compute the probability. Okay, exactly, right? So the probability definition is simply the number of favorable outcomes divided with the total number of possible outcomes. Okay, we will see examples. I mean, don't worry about too much about that definition, but uh, this is the exact probability, right? So we work with very simple problems so that we know the exact value of the numerator and exact value of the denominator, right? In the later part of the videos, when we use the Monte Carlo simulations, we will not know. It is hard to know how many total outcomes will be there and how many favorable outcomes will be there. So that's why we do the simulations, and we compute the probability using the simulations. Okay. Now let's start with the most simplest example. We have one coin. Okay. Let's say we are flipping a coin, right? When we flip a coin, we either get head or tails. Okay, either get heads or tails. So there are only two outcomes possible. Okay, only two outcomes possible, right? So that's the number of total outcomes. Now let's say it's a fair coin, not tampered coin. What do I mean by that is both heads and tails are equally probable. Okay, we can have tampered coins where, for example, we can bias the coin to always have heads, okay, or to always have tails, right? So here we are not going to work with such examples. We are going to work with the fair experiments, right? Or the fair coin or a fair dice, etc. Okay. All right. Now the first question: what is the probability of heads? Okay. Now in this case, the favorable outcome is only heads, right? I mean, because this is the simplest example, it looks too trivial. But when we go to a bit more complex examples, it becomes clear why we need to explicitly state what are all the possible outcomes and what are all the favorable outcomes. Okay, so the number of favorable outcomes is only one. Okay, then we compute the exact probability by dividing the number of favorable outcomes with the number of possible outcomes, right? Number of total possible outcomes. So in this case, it's 1 divided with 2. So we'll have 0.5. Okay. So this means when we flip a coin, there is 50% chance it can either be heads or it can either be tails. Okay. Both are equally probable. Then same story for a tails. Okay. So tails, again, we have uh, the favorable outcomes, it's only tails, and the number of favorable outcomes is only one. So the probability of tails is 0.5. Okay. Now let's say we are rolling a dice. Okay. You know dice has 6 faces and we have numbers or the dots on each face, right? We can count the dots to get the number. So on 6 faces, let's say we have 6 numbers on this dice. Okay. So the total number of possible outcomes, that's 6 for a die. Okay. Again, we assume it's a fair die, meaning all numbers are equally probable. So the first question we are asking, what is the probability of getting 3 on the top face? Okay. So the favorable outcomes, it's only 3, right? Only 1. So the number of favorable outcomes is only 1, which is just this 3, right? So the probability of heads is again, it's 1 divided with 6. So that's about 0.16. Okay. So in every 6 rolls, we will get 1 with value 3 on its face. That's what this 0.16 means, right? Now it start get interesting. Now we are asking what is the probability of getting an even number. Okay, so this time the favorable outcomes, right? So from the possible outcomes, what are all the even numbers? So number 2, number 4 and number 6, right? So the favorable outcomes are 2, 4 and 6. Okay. So this time we have the number of favorable outcomes 3. So the length of this list, let's say. Okay. So we have 3 favorable outcomes out of total 6 possible outcomes. Okay. So the probability again is 0. The probability is 0.5. Okay. So now you start to see this favorable outcomes, right? Now, let's say we are asking what is the probability of number less than 5? Okay, number less than 5. Now, again, from our possible outcomes, which are these 6, how many numbers or which ones are less than 5? Okay, so we have 1, 2, 3, 4, right? So, here we have our favorable outcomes 1, 2, 3, and 4. So, the number of favorable outcomes is 4. That means our sorry this is not heads. I should have updated the text, but so the probability is 4 over 6, which is 2 over 3, 2/3, right? 0.67%. Let me just correct. So this is the probability. All right. So again, let me remove this thing. We have 3 more. Let me remove all these 3. Sorry about that. All right. Okay. So here we are. So the favorable outcomes are 1, 2, 3, 4 because we are asking a question, the probability for the number to be less than 5. Okay. So the number of favorable outcomes 4. So the probability is 4 over 6 or 2 in every 3. Okay. Now let's step up the game. Okay. So we have 2 coins this time. Okay. So let's say we have 2 coins. We are flipping the 2 coins simultaneously. Now the possible outcomes, right? So we can have both coins heads and heads, right? So the first coin is heads, second coin is heads. Or we can have the first coin heads and the second coin tails. Or the third possibility is the first coin is tail and the second coin heads, and finally fourth one tails and tails, right? So these are all the 4 possibilities. Now we cannot have other possibilities, right? So a coin can only have heads and tails, and when we flip 2 coins, it can be either heads and heads or heads and tails or tails and heads or tails and tails, right? So we'll have 4 possible outcomes, right? So that's the total number of possible outcomes when we flip 2 coins. Okay. Now we are asking the question, what is the probability of at least one head? Okay, at least one heads. So from this one, if we look at least one head, so here we have 2 heads. Okay, that's a favorable outcome. Here we have an head, that's a favorable one. Here also we have a head, that's also favorable one. And this one, it's a tails and tails. So this is not a favorable outcome. Okay, so the favorable outcomes are heads and heads, heads and tails, tails and heads. So the number of favorable outcomes is 3. So the probability is 3/4. Okay, so 75%. That makes sense, right? When we are flipping a 2 coins, there is more chance to get at least one heads, right? All right. Now, let's say we are asking the probability of 2 heads. Okay, both coins should be heads. Again, we look at all possible outcomes. From this one, the favorable outcome is only heads and heads. Only heads and heads. This is only 1. Okay, this is 0.25. Now, if we compare these two, it is 3 times likely to get at least one head compared to two heads when we flip two coins. That makes sense, right? All right. Now uh, we are asking probability of one head as well as one tail. So we want both head and a tail. Okay, both head and a tail. Okay, so again going back here, this is not favorable, this is not favorable, so only we have these two as favorable, heads and tails and tails and heads, right? Again the probability is 2 over 4, that's 50%, right? And finally we are asking the probability for uh, two heads or two tails, right? Two heads or two tails. So here we asked only for two heads, whereas here we asking these two coins can both be either heads or both be either tails. Okay, again we look at our set space or all possible outcomes. So heads and heads, tails and tails. So that means we have again 50% probability. Okay, so as I mentioned, we are starting very basic. I'm assuming, I mean, this is for those who are new to probability. If you already know the probability, etc., you can skip the first few videos. Okay, it might be too boring for you. Now let's look at our final experiment, which is two dice, right? So this time we are rolling two dice. Now, as we know, each die can have six faces. Well, will have six faces, and each face has a number between 1 to 6, including 1 and 6, right? So the first die dice, it can have 1, and the second dice can also have 1, right? Let's say the first die has 1. Now for the second die, we have 6 possible outcomes, right? It can be 2, 3, 4, 5, and 6. And similarly, when the first dice is 2, now the second dice, it can again have values between 1 to 6. So 6 outcomes, right? 6 likely values. So in total, when we roll 2 dice, we will have 36 possibilities like this. Okay, 36 possibilities like this. Now let's ask the question, what is the probability that both dice have the same number? Okay, so this time our possible outcome space, it has 36 values. Now let's look for the favorable outcomes for this particular question, and that question is having same number on both the dice, right? So here we have 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. Those are the 6 favorable outcomes, right? So here we have the 6 favorable outcomes, and the number of outcomes, favorable outcomes, is 6. So the probability will be 6 divided with 36. So that's 1 over 6, right? So when we roll 2 dice, we will get the same value on both the dice 1 out of every 6 times, right? That's the probability. 1 out of every 6 times we get both dice the same value. All right. So let's look at one more. So here we have the probability of both dice having an even number. Okay, again we go back to all possible outcomes. So this time we are looking for both dice showing up even number, right? So if you look in this first row, the first die always has 1, right? So we can rule out this one, right? Because the first die is not even number. Now if you look at this row, yes, the first die is always even number, but the second die sometimes can have odd number, right? So the favorable outcomes are 1, 2 2, 2 4, and 2 6. So from the second row, we have 3 favorable outcomes, okay? 2 2, 2 4, and 2 6. And similarly, from the third row, we don't have any favorable outcomes because the first die is always odd number. And from the fourth row, we have 4 2, 4 4, 4 6. Okay, we have 3 more, 4 2, 4 4, 4 6. And fifth row will not have any favorable outcomes, and the final row will have 3 favorable outcomes, 6 2, 6 4, 6 6, right? Right, this is 6 2, 6 4, 6 6. All right, so the number of favorable outcomes is 9. The total number of possible outcomes is 36. So the probability is 1/4. Okay. And the final question, we are asking what is the probability of one die having an even number and the second one having an odd number. Sorry, I made number of mistakes in this video. Odd number, and the total value should be greater than 9. Okay, so we are rolling two dice. One dice should show up even number, one dice should show up odd number, and the sum of the two numbers should be greater than 9. Okay, again you can go through this. We can rule out all these values because some of them will be less than 9, right? So 6 plus 3 is 9, but we are looking for values greater than 9. So we can completely ignore the first 3 rows, right? And then if you look the bottom 3 rows, you will find these 4 satisfying the criteria, right? So the first criteria, at least one die should be even number, right? So if you look, there is one even number, 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 right? And the second criteria, there should be one odd number. Okay, so here we have an odd number, odd number, odd number, and odd number, right? So these two criteria are satisfied. And then the third criteria, the sum of these numbers should be greater than 9. So okay, 6 plus 5, 3 plus 9 should be greater than 9. Okay, so this one goes. All right, 5, 6. Okay, these two will go. These two will also go. And then the number of favorable outcomes is just 2. So it's 2 over 36. That's 1 over 18. Okay. It's very, very low probability. 1 over 18. So 0.05. Okay. So it's very, very unlikely, or how many times? Only 5 times, 5 in 100 times we will have one dice as even number, the second one as odd number, and the sum of these two numbers will be greater than 9. Okay, so that's only 1 in 18 trials. Okay, it is too basic. I mean, I know it is too elementary, but as I was said, probability is confusing for a number of people. So I thought I'll explicitly state all these statements so that you can read and understand if probability is something which you find it hard. Okay. All right. That's it for today. Again, maybe very quick summary. When we compute the probability only for simple problems, it is possible to know the total number of outcomes and the number of favorable outcomes, right? Which is what we saw here. And the probability simply is the ratio of the number of favorable outcomes divided with the number of all possible outcomes. Okay. All right. Thank you very much.